This next video is about significant figures. And you may have heard about significant figures from a friend who's had this class before. And significant figures are another one of those themes that will actually kind of run throughout the semester. So it's important that you understand what they are, how to use them early. Significant figures exist because of that uncertainty that are part of any measurement. And that uncertainty are those guesses that we make when we make a measurement. What the guess or what the sig figs tell us is that the more sig figs we have, the more confident we are about the accuracy of our measurement. In other words, the more decimal places that I have, let's say in a length measurement, the better chance I have of being right with that measurement because I have less chance of being wrong with my guess. Now, traditionally, the way that you count sig figs, and there are some videos out there in terms of counting sig figs, but the traditional way can get confusing. So I use a different method that's called the Atlantic-Pacific rule to determine the number of sig figs. So that's kind of the first step of what we're going to do, is determine how to count the number of sig figs a number has. And then the second part of what we need to do is take into account sig figs when we perform calculations that use measurements. So let me switch over to actually this document. Okay? So basically, this will walk you through it. You think of a map of the United States. Okay, in this case they say it looks like a cow, but it doesn't matter. Well, what you need to do is you need to remember that the Pacific Ocean is over here on the west coast, and the Atlantic Ocean is over on the east coast, okay, or the left side and the right side of the country, okay. Now, Atlantic starts with the letter A, and so does the word absent. Pacific starts with a P, and so does the word present. So what we're looking to see if is present or absent in our number is the decimal point, okay? So we're going to be dealing with either numbers that have the decimal point present or the decimal point absent. If the decimal point is present, we start on the Pacific or the left-hand side of the number, okay, and we work our way across towards the Atlantic side. These 3 zeros at the beginning don't count as sig figs. We start counting sig figs with the first number that is not 0, which is that 3. And then we count all the way across. So in this case, we'd have 1, 2, 3, 4 sig figs, as you can see down below here. Okay, so the number of sig figs is 4. So let's now take a number with the decimal point that is absent, this one right here. Okay, this one right here. What we do is we start on the Atlantic side of the number and go across this way until we hit the first number that is not 0, and we go across. So in this case, we start counting with the 4, and we go all the way across, like down here. 1, 2, 3, 4, 5. So there are 5 sig figs in this number. Okay, so that's always the rule. You start on the side, Pacific or Atlantic, dictated by the decimal point. You then move across towards the other side, starting to count sig figs with the first number that is not a 0, and then you count all the way across. Every single digit, 0 or not, after you start counting, counts as a sig fig. Alright, so let's move down here to the practice. Alright, so we're going to try to figure out the number of sig figs in letter A. In letter A, the decimal point is absent, so I'm going to start on this side. Oops, I keep doing that. This side of the number, and I'm going to move across to the Pacific side. In this case, I'm going to count the 9, the 6, or the 0 and the 6 all count as sig figs, so I have 3 sig figs in that number. In letter B, the decimal point is present. I know it's hard to see, but it is there. So I start on the Pacific side of the number and go across. In this case, the 1, the 2, and the 0 all count. So again, I have 3 sig figs. Let's look at letter C. Decimal point is absent, so we start on the Atlantic side of the number and we move across towards the Pacific. Neither one of those zeros count, so the only sig fig we have is the 5, so we only have 1 sig fig. In letter D, the decimal point is present, so I start on this side and go this way, and the first number I reach that's not 0 is the 7. So again, I only have 1 sig fig, and none of those zeros count. In letter E, I have a decimal point that is present, and I start on this side of the number and work across, and so all 4 of these count as sig figs. How'd you do? We will be getting some more practice with a packet that I have for you, as well as with your homework, in terms of determining the amount of sig figs. But it's not just about determining number of sig figs. We also have to use these in our calculations. So let me see if I can get us over. Okay, so the rules for using our sig figs in calculations. So once we've determined the number of sig figs that we have in a number, now we can actually have to use them in calculations, because for instance, if we're calculating volume, we have to multiply. There may be times like with displacement that we have to add or subtract. So the rules are slightly different for each. Okay, so with addition and subtraction, you're going to take your numbers and perform the operation that it's being asked to do. So you're going to add or subtract the numbers. Once you get your answer, then you need to change your answer so that it has the same number of decimal places, so places after the decimal point, as the one with the least. Okay, so let me give you an example. I take 2 measurements. I have 7.27 meters, and I'm adding 19.4 meters to that. When I do that math, I get 26.67 meters. Now that's what ends up on my calculator. But because this second number only has 1, so in other words, my guess for this one is here, my guess for this one is here, I need to make sure that my answer reflects this. So this one has 2 spots after the decimal, where this one only has 1. So I need to change my answer so that it only has 1 place after the decimal point. So if I look here, that 7 is going to round my 6 up to a 7. So my answer would be 26.7, and the unit is meters. That's addition and subtraction. In addition, we can also do multiplication and division. So let me just drag this down here. With multiplication and division, you perform the operation again, so you multiply or divide the numbers, and then when you record your final answer, it should have the same number of sig figs, not decimal places, but sig figs, as the one with the least. So let's say that I'm taking 0.02 and I'm dividing it by 0.0034. When I plug that into my calculator, I get this, 5.882352941. Now, I can't leave my answer like that. This isn't math, okay? So if I take a look, if I count the number of sig figs that 0.02 has, it is 1. And the number of sig figs that 0.0034 have, it is 2. So my answer can only have 1 sig fig in it. Now, when I'm reducing this, I need to make sure it has close to the same magnitude. In other words, I wouldn't want to put my 1 sig fig here and put all zeros in front of it. Okay, because 0.000000001 is not close to the same thing as 5.88. Okay, so my 1 sig fig would need to be here instead. So I actually forget about all of this. Don't worry about it. What I do need to do is look at that 8 and see how it influences my rounding. My 8 is going to round my 5 up to a 6, and so my final answer for this would be 6. Most of you understand the concept, but quite honestly, it's the application and actually making it go into the final number of sig figs. This is something that will get easier the more practice that you do. Okay, a couple of things that you need to know about here that weren't listed. Any conversion factor that we use, like 12 inches equaling 1 foot and 100 centimeters in 1 meter, you don't count sig figs in those. They don't count towards the determination of the number of sig figs. So if you're using a conversion factor, don't include them. The only thing that counts for sig figs is measurements, and that's why we include it here. When I have a number that is in scientific notation, the rules apply to the first part of the number written in scientific notation, the 1 with the decimal. And then it also talks about when multiplying you add the exponents and when dividing you subtract. So let me show you something here. If I have this number, okay, this is the only component that actually counts for sig figs. And in this case, it's always going to be Pacific rule because the decimal point is always present in scientific notation. So in this case, this has 3 sig figs. Okay. If I were to write that out, 47,600, and apply my Atlantic rule, because that's how it would be written, I would come up with the same number. Now, this is probably one of the other things. You have to make sure that you round properly. Look at the digit beyond the one that you will write down. If it is less than 5, don't change the number. If it's 5 or more, you round up. So what you actually have is a practice packet that talks about sig figs, why we use them in science. Because remember, this math, and not in math, because math doesn't deal with measurements. So that's important. And it also gives you some more time to not only count sig figs, but also to the harder part, to try to get comfortable using them with these operations.